Here's some more circle review problems that we didn't cover in the first half, the first review. It has to do with equation of circles and angles and segments with tangents and secants. Like, for instance, I know that's a lot of math words, so you're like, what? Well, first we'll do angles. Let's say if they give you x, 30, and 100. Remember, if x is in the center, it's called a central angle. It's the same. If it is literally on the circle, it's inscribed, so it's half. But if it's just two chords, if you extended it, made it lines that intersect, it's always somewhere in the middle. You're going to add, it's called the intercepting arcs. So 100 plus 30, divide by 2, 65. An interesting thing is, of course, if that's 65, you know this right next to it, since that makes a straight line, it adds up to 180. So 180 minus 65, 115. And then, of course, you got some vertical angles going there. Now, you could say, let's say 50 and 62 and want that one. Same thing, it's on the inside, so you add them up, divide by 2, 56. Now, let's say it's on the outside. If it's on the outside, you subtract the intercepted arcs and divide by 2. So if you have, like, let's say a tangent and a secant, where this is 20 and this is 140, subtract them, divide by 2. Now the figures, of course, can get a little weird from time to time. Let's say they gave you something, we'll say that's a tangent. Let's say they give you, this is 40, this is 200, and they want x. Well, they missed and they didn't give you this piece. You've got this piece, you've got this piece, but you're missing that one. Well, if that is 240 degrees, you know the whole thing is 360. So that leaves 120 left. And if there's 120 here, 40 there, 120 minus 40, 80, divide by 2. You can even have two tangents. Let's say this is 300. Same principle. The two tangents are cutting it into two parts of the circle. So 360 minus 300, 60. And then do your normal. Subtract, divide by 2. Now, notice an interesting thing. Those will always add up to 180 as long as it's two tangents. So like if I said this over here was 40, you know this intercepting arc, 140. And then, of course, if they wanted that, 360 from minus 140, 220. So that's just a little shortcut that always works. Now let's say, and remember this one's along the same lines, but remember this is basically just an inscribed angle. If this is 50, that's 100. If this is 100, then that means this is 260, because the circle adds up to 180, the line adds up to 180. Now then, the segments. If you have two chords, remember this times this, or 6 times x, equals 3 times 8. So if 6x equals 24, x is 4. Sometimes they could try to be tricky and say like 5 AB is 5, AC is 13, DB is 2, I don't know, BE is 12. Who knows what we'll end up with. So we got 2, we got 12. Oh, we have no variable. Let's find BE. So we got 2, and I got x, so that part we know 2x. And I've got AB is 5, and AC is 13. Well, if this is 5 and the whole thing's 13, that's 8. So 5 times 8, 40. X is 20. So if it's 2 chords, the lengths of this chord, the product of them, or multiply them, will always equal the product of the other one. Now let's say I have 2 secants. See, I've got 3, 8, 4, looking for that. Well, remember this is the part outside, the ratio of the length outside to the whole thing, which is 11, equals part outside 4 times the whole thing, which is x. So 33 equals 4x. 33 over 4. Let's say 5, 2, 3. And let's say this is x. Don't make it harder than what it is. You actually could find out what the whole thing is and then subtract 3 from it. Or you could just deal with the variable. So 5 times the whole thing, 7, equals 3. And if you want to, you can say y, or you could do x plus 3. This way is not too bad. 3x plus 9, if you distribute, subtract the 9, go from there. Now if you did y, 35 equals 3y. So 35 over 3, which is 11 2/3. So if the whole thing is 11 2/3, subtract 3, 8 2/3. Or you still could do the same, 35, 3x plus 9, because outside times the whole. Subtract the 9 to get 26 equals 3x, which is 8 2/3. So either way, it's just sometimes if you put distributing in that, you can make careless mistakes. But outside times the whole, outside length times the whole. And last but not least, let's say you have a tangent. Well, notice how the outside and the whole, that side's normal. But notice how the outside and the whole is the same thing, or that would just be 8 squared. So this squared always equals outside times whole. So 4x equals 64, 16. Let's say you had an x2 and a 10. X squared equals 2 times the whole thing, 12. X squared is 24. Square root of 24. And last but not least, equation of circles is one more thing we did. to finish this chapter up. Remember if they give you the equation to find the center, the standard form where the center is HK looks like this. So notice how for it to be positive, that means minus is part of the formula. So the center is positive 2, positive 5, and the radius is the square root of 36, which is 6. Let's say x plus 4, y minus 1. Well, the center is going to be opposite, so negative 4, positive 1. Radius is 5. Another way you can think about it, it's what makes this 0. What plus 4 equals 0? Negative 4. What minus 1 equals 0? Positive 1. I could also give you the center. Let's say 3/8, radius is 4, and say you give me the equation. X minus 3 squared plus y minus 8 squared equals 4 squared. There you go. Sometimes they try to be tricky. Let's say if you did 0, negative 1, radius 9. Well, notice how you could do x minus 0 squared, 9 squared or 81, or you could just say x squared since the 0 is understood. So anytime you see like an x squared and a y squared by itself, that just means the center is 0, 0. So if you wanted to graph it, 0, 0, radius 3. There you go. If I wanted to graph this one, positive 3 up 8, 4 in all 4 directions. There you go. Well, this was just a hodgepodge of the second half of the chapter. I hope this was of help to you. Good luck on the quiz.